So in the last video we saw the RLLearn method. Now we will get into the RLRecommend method. Now this is again in the same Python file, in the same file which we did the RLLearn method, RLLearn class rather. So add this class, the code in the same Python file itself, and make a class called the RLRecommend. So let's look at this is a very long class, so we'll go method by method. Different methods are there, and these methods are for recommending the products. So we'll go one by one. So the constructor class is again like the earlier class, the RL learn method, wherein we pass the customer details, get the date which is for the periods, and then we get the month periods, and then we create this consolidated data frame for each state ID. For each state ID we create the consolidated data frame. As you know, the contents of this data frame would be each state ID and the different products under the state ID and the quantities of the product. So that's what this rewardful data frame is. And then we make it as self.custdetails and self.conf and self.rewardful, so that it's these details or these data frames and the configuration files are available across all the different methods in this class. Now we'll go through the first two methods. The first method is wherein we have seen this in Post5 in the prototyping method. So here these are to get unique the unique values for segments, months, periods, and days. So we are getting these unique values to create these state IDs. So the next one is to the sample the segments. Okay, so here we are using the unique words method here to get all the unique segments, months, and month periods. Okay, and this particular method is to get a state ID or sample one state ID, because earlier we said that we don't have a real system. So when we don't have a real system, we have to get a state ID. So in a real system, if there are customers in the system, so once the customer logs in, we know that okay, this customer belongs to this segment, and this customer would have logged into a specific month or one period or day. So you get the context from there. But since in the absence of a real system, we are simulating this context. So that's what this state sample method is for simulating the context and getting the state ID. And we saw during the prototyping method that one of the first methods is to check whether a particular state ID exists for those dictionaries. So we have 4 dictionaries, which is your count dictionary, policy dictionary, reward dictionary, and the recommendation count dictionaries. So if the state ID do not exist for those specific dictionaries, then we will get a null value and we'll get an error. So this method is to just check those whether the state ID exists. If the state ID do not exist, then we create those instances of those state IDs and in the dictionary. So the first is, and there is a subtle difference here from the prototyping phase, wherein in prototyping phase these were all dictionaries. Now these dictionaries are extracted from the MongoDB as collections, so which we will see later on. So this is the part where we will extract it from the MongoDB. We'll see that once we look into the main file, but just remember that these are specific collections which we extract, or as dictionaries we extract from MongoDB. Now if the state ID do not exist, these would be null values or none values. So that's why we are checking whether count dic is none. So if the count dictionary is none, then the state ID did not exist, and that's why and then we initialize this. So we first create the specific dictionary, count dictionary, as a dictionary, and we create an inner dictionary for this. And we create the dictionary, and the key value of the dictionary would be the state ID, and the value would be another inner dictionary, and this inner dictionary we'll use to store the product IDs and the quantities. So that's the way it is. So for each for each of those things, each of the dictionaries like count dictionary, policy dictionary, and reward dictionary, we do the same thing. And if the recommendation count dictionary also, we do it separately, because there could be cases where we have all these other dictionaries, reward dictionary, policy dictionary, and count dictionary, but recommendation count dictionary may not exist. So that's why we are treating these separately. Okay. And then so if the next method is to look into the MongoDB collection itself if the recommendation count dictionary exists. Again, we have to treat this separately, because as I said earlier, the reward dictionary and other dictionaries may exist, or and you still have a case when the recommendation count dictionary do not exist, because we might not have recommended that product. So that's when we have to check that particular reward count dictionary if it exists in the MongoDB. So this is the method, or this is the line for checking whether the particular state ID exists for those for that particular reward collection. So RL record track is the collection to track whether a particular product has been recommended or not. So we check that, and if it exists, you will get either if it exists, it won't be a none value, but if it doesn't exist, it's a none value. So if it doesn't exist, we are inserting just one record for that, as a state ID, but it will be an empty set, but still we are inserting a record there for that state ID. So that is what is being done here. Now we'll get into the next methods, next two methods also. So the next method is to we have seen during the prototyping phase, same thing, wherein we sample the products from a segment. So we take all the products of a segment, whereas this is all the products of the segment which we want, and then we sample according to the number of products we have. So suppose we want to recommend only 10 products, we sample only 10 products from this. This is required, this particular method is required when the number of products which we want to recommend is greater than the top products which we already have for that state ID. We'll see that in the sort list the method. So in the sort list method, we say that top products is the sorted list of products based on the frequencies in which the product is bought. That is what this is there. We need the top n products or top 10 products we want. So that's this line. Now if this top products is less than the number of products which we want, because we want to recommend say 10 products, and we have got the top products for that particular state has only 5 of them, just because for that specific state ID these products have not been, so many number of products have not been bought yet. Then what we do is we sample these products from the segment. That is where the earlier method called the seg products is used. So while the length of n products is less than number of products, so we first get the list of top n products, which we take the differential between the number of products and the top products which we have already got, and then you add you get the new list which will be equal to the number of products which we want, that is top products plus segmented products, which is line 189, and we get the new list which is the top product. So the top products would be, in case there is a in case it is less than the top products, so we'll sort it based on the frequencies in which it is bought. So that is what this method is for.